Welcome back to COBOL for the mainframe. This is episode 5 where we will be talking about logic flow inside the procedure division. If you downloaded the very simple program listing from episode 4, we will be looking at it as our first example. Bring up the sample program 1 and move down to the procedure division. Remember, you can place the cursor on the line you want at the top and press F8. This works if the scroll at the top right of the screen is set to CSR for cursor. COBOL logic is typically procedural. While object-oriented programming is possible now with Enterprise COBOL for z/OS, you won't see it as the norm in a mainframe environment, at least not yet. The most standard way to code in COBOL is the structured method. You can see the first section, or paragraph in the procedure division, is 0000 main. This is the main logic driver, and the idea is to start and end in this paragraph. The first two lines of 0000 main instruct the program to perform 0100 initialize through 0100 initialize end. All this means is to start at the paragraph header and do each instruction all the way through the paragraph named 0100 initialize end. As you can see, the only instruction in 0100 initialize end is the exit verb, telling COBOL to exit the paragraph. This may seem like a bit of overkill to have a separate paragraph just for an exit, and it is for this particular paragraph, but it makes a program easier to follow when paragraphs have many instructions and a clear exit is needed. At this point, control goes back to the last point in 0000 main and flows to the next statement, which is another perform. This time we will perform 0200 process through 0200 process end. This paragraph is where most of the work gets done as far as creating the record we wrote out in the last lesson. You can see the values being moved to fields and the actual record right. When processing goes through 0200 process, in the exit it done and control goes back. Control goes back to 0000 main and performs 9999 closeout through 9999 closeout end. This paragraph simply closes the output file we built and goes through another exit to return control back to the main paragraph. Don't worry if this seems like a lot of code for a very simple program. In this case it is, but once we get to more complex logic, the advantages of this method will be apparent. This would take us back to the last part of the main paragraph. The program will execute the display and then stop run, which ends the process. That concludes the basic logic lesson. I thought it might be interesting to talk a little about JCL, or Job Control Language. You have seen it in previous lessons when we are ready to run a test on the programs. However, no explanation has been done on what it does and how it works. JCL is the language used to run a job on z/OS. It is very important to have a good understanding of it to work in a mainframe environment. The sample shown here is to run our very simple program 1, which moves some fields and creates a file. JCL tells the system about programs to run and how to allocate resources. The first line in the member is called the job card. It names the job and specifies classes for the run and output. On a mainframe, jobs run in classes that are normally set up based on whether the job is test or production. Production jobs are for real customer data and are given a higher priority than test jobs. The message class and message level parameters are for disposition of job listings and report defaults. The next statement specifies the job lib. This is the location of the executable file for the program. You will see later that locations can be specified for the entire job or for a specific step. If this was not present, the system would not automatically know where to find the executable and the job would fail. z/OS has what is known as a linked list that would be set up by a systems group. It contains a list of libraries to be used without specifying a job lib, similar to a path statement on a PC. The next step is what is commonly referred to as a BR14 step. It executes an IBM utility called ifbr14, which does nothing. However, it is used to delete a file before a step that will create the same file name to avoid an error when trying to create a file that already exists. The name comes from the standard assembler practice of branching to register 14 to end a program, meaning this utility essentially sends a return code of 0 back to the system. In doing so, the files allocated in the step will use the parameters in the disp for file handling. The first parameter on the DISP, or disposition, tells the system the state of the access when this step is entered. In this case, we see mod or modify, meaning the file is expected to already be present and we are going to modify it. The second parameter tells the system what to do with the file if the step completes successfully. In this instance, we want to delete the file. The third parameter tells the system what to do if the step has an abnormal end, or abend for short. In this case, the file is deleted. Notice what we did with the dis parameter in this step in conjunction with IFBR14. The whole purpose of it was to make sure the file we are going to create in the following step is deleted so we won't get what is called a catalog error, meaning we tried to create a file that is already there. If the file was not there, the mod would be ignored since it is simply the status. The IFBR14 execution should return a good or zero condition code, so the second parameter would delete the file if there. In this case, the third parameter is not necessarily needed, but it's best practice to include it. Also notice we coded the space parameter to effectively allocate no space for the file, and the unit parameter points to default system space. The next step of the job executes our program called program1. You can see the sysprint, sysadump, and sysout statements for various output that would be routed for viewing either as reports or job listings. We will cover these later. For this lesson, we will focus on the file being created by the program. This time you notice the parameters of the disposition are different. The file is treated as new on entering the step. If the program ends normally, the file will be cataloged or saved. If the program ends abnormally, the file will be deleted. A little trick that can be used for debugging a program that is failing would be to set the third parameter to catalog the file even though the program fails. That would allow you to see the records written before the failure. Sometimes that can be useful. The other things you see are space and DCB on the DD1 statement. These are for defining space record attributes and will be covered in the next video. That concludes this episode. If you have questions or comments, please post them and we will get back to you as soon as possible. You can also email if you need to. If you like the content, please subscribe to the channel and spread the word so we can keep it going. Thanks again for watching, and we will have the next episode out soon.